What's up, team? Today we're talking similar right triangles, learning target down here. I can determine if two right triangles are similar, and I can use scale factors to create similar right triangles. I can also identify opposite and adjacent legs given to a given angle. We're going to talk about all those things, and it's not as crazy as it sounds. First things first, what are similar right triangles? They are two or more right triangles with congruent corresponding angles and corresponding side lengths that are proportional. So let's unpack that. The first part's easy, the second part is a bit of a mouthful. So the first part, we have triangle A, B, C, triangle D, E, F. The first requirement, congruent corresponding angles. Well, we can see that that's pretty quickly that's the case here. We have 90-degree angles. Those are corresponding. Those are congruent. We have 25-degree angles, corresponding and congruent. 65-degree angles, corresponding and congruent. Check. Now, the other piece of the puzzle, this is going to take more time from all of us here. So corresponding side lengths that are proportional. So what we need to do here is set up some ratios and see if all the ratios are indeed equal or they're proportional here. So corresponding sides. In this case, we have side DE is corresponding to AB. So I'm going to set up a ratio here. I'm going to put 27 over 4. And what I'm doing here is I'm setting up a proportion here, and I'm trying to see if all three of these ratios are equal. That's my hope. If they're all equal, it doesn't matter what they are, as long as they're the same, then we have congruent corresponding sides here. So let's keep going with this. The other leg is, we did that one, 20.25 over 3. And then I'm doing an equals with a question mark. Reason being is the question mark is I don't know. I'm checking it out. I'm setting it out. I'm setting it up. I'm hopeful that they're equal, but I don't know. The hypotenuses here, we have 33.75 over 5. So what I'm going to do now is I'm going to grab my calculator. I'd encourage you to do the same. And I'm just going to start plugging these things in. We know that this is 27 divided by 4. Let's see what happens. I don't think it's going to be a whole number. It ends up being 6.75. So 6.75, let's capture that. Let's check the next one now. 20.25 divided by 3. Oh, that's also 6.75. That's good. That's good. And if the third one is also 6.75, then we absolutely have similar right triangles. 33.75 divided by 5. Bingo, 6.75. That's a win. So what that means is we have what's called a scale factor. That's a new word, and it's going to be a word that we use, scale factor. All it means is for this set of similar triangles, we have a scale factor of 6.75, meaning that corresponding side lengths of the larger triangle are 6.75 times the length of that they are the smaller triangle. So say we just started with this, and I give you the fact, hey, you have a scale factor of 6.75 for another similar triangle. You would then take the three side lengths, multiply them each by 6.75, and you would land at this exact triangle here. Scale factors aren't always in decimals like that. In fact, more often than not, they're going to be whole numbers, 2, 3, 4, whatever the case may be. I gave you a tricky one on purpose so we could practice it right off the bat. Okay, here's the second half of what we're doing today. Interestingly enough, we're just working with a single triangle. This will make more sense in the next lesson. This is just to get us warmed up for what we're doing next. We're going to talk about adjacent and opposite and adjacent legs. So let's first talk about legs and the different parts of a right triangle. A right triangle has three sides. We all know this. Every triangle has three sides. A right triangle, however, has one hypotenuse and two legs. It's very important that we keep that straight. The hypotenuse is the side, it's the longest side, it's opposite of the 90-degree angles, but it is not a leg. You may not call a hypotenuse a leg. They're different things. The legs in this example are AC and AB. They're the ones that touch the 90-degree angle, whereas the hypotenuse is opposite of the 90-degree angle. It never, ever touches it. So legs and hypotenuse. That's key to understand as we dive into this here, and I'll explain more as we wrap it up. So opposite is across from. So if we're looking for the leg that's opposite to angle B, so first we need to locate angle B, and we're just going to look directly across the triangle. So in this case, the leg that's opposite of B is leg AC. Another way to think of it is this is the leg that doesn't touch B. It never touches B. This leg does touch B. The hypotenuse touches B. This is the side, the leg that does not touch vertex B. So I'm going to say C over here. Next, the leg opposite to C, angle C. Angle C is here, opposite is over here, that's AB. Next, let's talk about adjacent, which means next to. So the leg adjacent, or the leg next to angle B, we have angle B. It is adjacent to the hypotenuse, but that's not a leg, so we're not gonna talk about that right now. We're talking about this leg here, AB. And then adjacent to angle C, again, it's adjacent to the hypotenuse, but that's not a leg. So AC is the leg that it is adjacent to. Notice how I didn't ask what is the leg opposite or adjacent to angle A. Two reasons for this. One, if I ask for, well, let's just explore this. If I ask for the leg that's opposite of angle A, we would go to A, we'd go straight across. You might say like, oh, it's BC. Well, that's just not the case because BC is not a leg. So it's kind of like how you have 5 fingers but one's a thumb. I can't call this finger a thumb because it's not a thumb. In the same way, this here is not a leg, it's a hypotenuse. So there is no such thing as a leg that's opposite to angle A in this case, or any time opposite the 90-degree angle. Similarly, but different, if you ask for the adjacent leg to angle A, or adjacent to the right angle, there's 2 responses. You could say AC is adjacent to A, you could also say AB is adjacent to A. You won't get asked that question. That's never going to be on a quiz. It might come up sometime in the future, but I don't anticipate you seeing that. Super important that we understand opposite and adjacent angles. We're going to spend a ton of time using this language, both in our next lesson and then after spring break as well. It's a part of what we call trigonometry. You're going to see a lot of it. So make sure you're extra comfortable understanding opposite and adjacent side legs. Okay, with that, your practice problems are in our classroom. Please shoot me an email or something if you have questions. I'd be happy to help you out. You got this.